Hello, and welcome to, well, ship shape and running on gas. Well, the running on gas part is easy. Today's main topic is gas turbines, but the ship shape part, that's something different. That's something new. That's the reason today I'm treating myself to some celebratory iron brew. So, ship shape has gone live today. Ship shape is myself, Clarke Naval, Gareth, John Bull, call him what you will, and Dr. Dan Van Freeman. Ship shape is the four of us who went to Canada last year, and this year we want to go to Australia. But the thing is, we want to do big trips for you all. Big history. And when I say big history, I mean really, really big history. We have the equipment, mostly. Some of it we're buying before we go, but we'll buy it out of our own pockets. We have the knowledge to a large extent, especially when there's all four of us together. We have a plan. It's a whole month. Because to make it worthwhile in terms of, or viable in terms of the amount of stuff you need to do, let's put it this way. If I want to get a flight to Canada to go see Haida again, I can. It'll be expensive, but I could do it. I could save up money and do it quite easily and pop out there, and it's a few hours flight, but it's broadly speaking easy, and I could go out there for 3 days, come back, just see Haida. That'd be worthwhile. And there's enough stuff nearby Hamilton that I can go and do that from Hamilton and find stuff. But Australia is massive. Let me explain this. It is absolutely massive, what we're talking about. There is one ship we want to see when we're going from Perth, and we're going to literally fly to the nearest airport. Get in a hire car, go see the ship, go back to the airport and fly back to Perth, because that's easier than going and staying on there or trying to then fly from there onwards. We are going to be looking at, 21 ships, broadly speaking, in 22 days. But that is a very minimal amount to be talking about, because honestly, we're going to be going through all the museums, we're going to be going through their archives, we're talking with a couple of universities, and I'm open to other universities and other places, historical societies. If they'd like us to give talks while we're there, we're more than happy to do that. And basically the entire plan is to do a massive history bonanza. And all the naval history in Australia, and there is so much. I think there's an introductory video on the website, and I think in it I said there are engines from the Crimean War. And I probably put more invective behind that because it's now sunk in a bit more, but still, there are the only surviving engines you can find in that level of quantity and quality from the Crimean War are in Australia. Let me restate that again. The best quantity and quality of engines surviving from vessels which actually served in the Crimean War, not in the UK, not in Crimea, which of course is disputed, not in France, no, they're all in Australia. It's absurd, but that's where they are, and I love it. But to do Australia, it is literally the other side of the world. It is literally us going there, and we're going to be having to spend about 3 to 4 weeks. And that's going to cost a lot of money. And so that's what we're asking for your help with. But please go to the website. There's a link down below, and you will find out far more information. And there is far more stuff. And there are challenge coins. And there is a little video I did with challenge coins myself. And yeah, it'll be good. It's good. It's gonna be amazing. It's gonna be Canada ramped up. And if it works, conferences, Japan, potentially South America, Scandinavia, we're looking at a Scandi flick, Italy, all sorts of options become a possibility. We might even tell Drac to stick his tour guide hat on and take us around America, because we know he's been and done the American ships, but we haven't. He could be our tour guide. It's gonna be fun, is all I'll say. Anyway, to running on gas portion of this video. And also, before I start, I have to say a big thanks to Gareth, a big thanks to Dan and Drac, because putting this together has not been easy. And to be fair, probably as the one who has the least reliable income stream, broadly speaking, from their employers, I'm probably the most dependent on it. i.e. the least able to find by other means the ability to do the trips. And it wouldn't be possible for me to even dream this big without them. It would certainly not be. Anyway. Let's start with running on gas. Now, gas turbines. They are this thing which has a wonderful history. A really wonderful history, because quite often I get variations on questions of people going, so, what other options are there? You know, why didn't they get to gas turbines earlier? And the fact is, I can always point out to the fact that, you know, the first gas turbine powered ship to be commissioned was HMS Asante. Unfortunately, that's the Type 81 Tribal Class frigate commissioned in 1961, not the Tribal Class destroyer. So they miss out on World War II by 16 years, and they miss out on being viable for World War II by roughly 30 years, you'd think then. But it gets very interesting once you start looking at the timelines, and once you start going through the various options for those timelines and start going, hang on. The first patent for a gas turbine engine was patent number US 635919, patented by Charles Gordon Curtis in 1899. Yeah. In 1903, Erigus Elling, a Norwegian, built a gas turbine that's able to produce more power than needed to run its own components. 1906, there's a water-cooled combustion chamber engine produced in France. In 1910, the Holsworth impulse turbine achieved 150 kilowatts. Nikola Tesla had a Tesla turbine, as if that ever surprising. And things go on. And even in the 1930s, well, Frank Whittle started his work in the 1920s and spent a large chunk of the 1920s trying to get the RAF to agree to develop the gas turbine for jet propulsion. So honestly, the question becomes, why didn't they? And the reality, shameless book plug. I love the shameless book plug. The reality is advantages versus disadvantages. It's the old question. How do you overcome the problems of gas versus the other systems you already have? Because you've got geared steam turbines coming in, you've got high pressure steam. This is also the period where the pressure of steam is going up and up and up as you are efficienting and refining that technology. So there is that quite big problem for gas turbines. The fact is, at the beginning, they are nowhere near as useful as steam turbines. But let's have a look at them. Let's start off with disadvantages, because these are what stop them taking over from those other marine engines that quickly. Disadvantages. Core engine costs can be high due to use of exotic materials, which are also difficult to get hold of in the 1920s and 30s. Less efficient than reciprocating engines at idle speed. Longer startup than reciprocating engines. Less responsive to changes in power demand compared to reciprocating engines. Characteristic whine can be hard to suppress. Now, some of these things worry a ship, some of them don't. Advantages. High power to weight ratio compared to reciprocating engines. Smaller than most reciprocating engines on the same power rating. Smooth rotation on the main shaft produces far less vibration than a reciprocating engine. Fewer moving parts than reciprocating engines, resulting in lower maintenance costs and higher availability over its service life. Greater reliability, particularly in applications where sustained high power output is required. Waste heat is dissipated almost entirely in exhaust, always useful. Lower peak combustion pressures than reciprocating engines in general. High shaft speeds in smaller free turbine units, although larger gas turbines employed in power generation operate at synchronous speeds. Low lubricating oil costs and consumption, can run on a wide variety of fuels, very low toxic emissions. Most of those are later ones. And by the way, that engine you can see poking out there is of the same type, but not the exact same model, as is the first jet turbines fitted into ships, or rather fitted into MGB 509. That was then made into MGB 2009. Fun. They're nice engines. So here you go. Here are your key people. There is Charles Gordon Curtis. I have to say they all spot a fine moustache. I mean, have you ever considered it? When I was showing you the pictures of the steam-powered and the steam-power engineers, most of them had a fairly decent beard. The jet engines all seem to be fine moustaches. I'm not saying there's a correlation between whether your moustache makes you a gas turbine guy or whether a full beard makes you a steam guy. I don't know. But there does seem to be something going on here. Now, this is Edgar Elling's engine. Now when you look at that, that was an absolutely amazing thing. It won him awards. In fact, all three of these gentlemen won some awards, although poor Whittle frankly suffered from the dual problem of being British and, well, not being from the right club in the RAF, it seems. He has many issues joining the RAF. The guy keeps trying over and over again. There's actually part of me which wonders if the Royal Navy had its own independent air service, whether he might have ended up in that, because he actually ends up joining the Royal Air Force under a false name to get through the acceptance, because he failed a second time because he wasn't tall enough. This is despite him going away and managing to put on 3 inches. If I could go away and grow 3 inches, I'd be a very happy person. You know, that he goes away, gets on a good diet, exercise, and puts on 3 inches of height. That's gonna be painful at the age he was when he went through it. Frankly, I'd have thought that would have made him given him entry, but oh no, the RAF were very fussy. So yes, there is the potential that he could have ended up a Royal Naval aero engineer, in which case, if the Royal Naval Air Service, so goodness knows what would happen then. Well, I do have a fairly good idea what would happen. Because again, he ran into the problem that pretty much everyone trying to sell faster, lighter engines to the RAF did in about the 1930s, the early 1930s period. That they are looking at multi-engine bombers because they want to carry a large amount of weight, because the bomb will always get through. Speed, it's lovely, but it's not as essential to the Air Ministry. And it's a really interesting debate going on in the Royal Air Force, but lots of things do suffer from this sort of weird grouping. Curtis, he is the real power behind gas turbines. He received the Holly Medal from the ASME. That's the Association of Mechanical Engineers in 1950, and received the annual award of gas turbine division in 1948 from ASME. But he developed this in 1899, and he's still alive in March 1953, having been born in 1860. So you think about that, it's almost 100 years from him being born to a full warship going to sea with gas engines, gas turbine engines. Now, this is the actual turbine fitted. And as you can see how it's turned from being looking like a jet engine, this is its sibling, to a marine turbine. It's not an easy conversion, but yeah. And the Royal Navy started off with small ships, put it in, give them high power, high speed. Because you think about it, and this is the interesting thing, people often start to go, whenever I talk about gas turbines and people start talking about World War II, they sort of go, well, you know, if we had them, you think of the speed of destroyers and cruisers would have got up to, and I'm sort of going, yeah, no, it would have been things like, these would not have been steam gunboats, they would have been gas gunboats. And, fudge me, they would have been pocket rockets. Just in the nicest way, if you're putting in a motor which delivers the same amount of power, an engine that delivers the same amount of power for a third to half the weight, the power to weight ratio goes through the roof. At which point, those things with their steel hull and very large capabilities probably no longer need to worry about fighting E-boats and Schnellboats, as they are called as the Germans call them, with guns. They can just ram them at high speed, go through them and aim for the next one. It becomes a very high speed version of the Thunderchild, which is a steam ram from War of the Worlds. There are a few other steam rams in history. Basically, the point of this all, the point of everything, was to give them a speed capability. To give them a speed advantage. And to learn about these engines, because immediately the British did start putting them in their next generation of patrol vessels. And then they sold them to the Norwegians. But, you know, they built them. So, one of the things though you'll notice, those disadvantages. Disadvantages. In less efficient than reciprocating engines at idle speed, or at slow speeds often. This means that often, when installing them, it's not just a gas turbine, especially in the original ones. CODOG, combined diesel or gas. If you're the Russians, for their first vessels, they went combined gas and gas. With one, I'll talk about that in a second. It's a one gas turbine orientated for and designed around being the most efficient at low revolutions, and one being orientated around high revolutions. It's a fun thing, but combined diesel or gas, basically you have a diesel engine which provides power for cruising speed and below, and you want to go fast, cha-ching. Gas turbine on, diesel engine off. Hence it's the or gas. Combined diesel and gas. Well, this is when it gets really fun. Really, really fun. This is when you want something faster and longer ranged. So this would be what you probably fit in your destroyers, especially if you were the German Navy and gas turbines were around prior to World War II. Because then you could have your diesel engines run and give you a very good speed up until cruising speed, and they keep on running. And then you turn on your gas turbine to give you basically the equivalent of a rocket motor attached to a swordfish, i.e. those rocket-assisted takeoff systems they have. And you turn on the gas turbine, and suddenly your speed goes from nee to nee. That's the idea, anyway. But as you can see, it's also quite complicated in terms of the number of gearboxes and gearings, which again is why I think the Germans would have gone for it, because let's be honest, if you can have the most complicated system imaginable, then you're usually the German Navy. CODLAG, right then, combined diesel, electric and gas. Now, this is an interesting system because this takes the diesel generators away from the actual shafts, sticks them on an electric motor. Now this is interesting enough. This is the system which I think it would have been interesting for the US Navy to have pursued if they managed to get it before World War II. Because again, this sort of system would allow them great range for their capital ships. Think about that for your carriers, for your Iowas, etc. They could have diesel generators which provide enough power to keep their electric motors going at the speeds they need to run at cruising speed. And then when electric motors start to get a little bit whacked out for high speed, whack on the gas turbine, give them the power. Type 81s. The first gas-powered warships. Now, these vessels often get no respect. Absolutely none. And when I'm through with all the small vessels and different classes I want to do from World War II, World War I, and the Age of Sail era, and I start on the post-World War II era, this class is probably going to be the first class to get any attention from me. Because they deserve it. They have many shortcomings. I do agree. And originally they had planned to build 20 plus vessels. And so the cost of development was going to be spread across all of them. But instead, 7 were built. and only 4 would have been built if it had been possible to cancel the contractual commitments the Royal Navy had entered into for the supply of the complex engines and machinery for 8 frigates. Unfortunately, they were small. They were only a little bigger than the pre-World War II Tribal-class destroyers. And they were 200,300 tons in standard, 2,700 tons fully loaded. So, and realistically, they are supposed to take over the roles of the Black Swan class sloops and Lock class frigates, and were originally built and ordered as sloops, not frigates. So they're reclassified as second class generation frigates to maintain the frigate numbers in the 1960s, at which point they're not really the best frigate in the world because they're designed to be a sloop, which is supposed to be a very good anti-submarine warfare vessel, but let's be honest, frigates have become specialist anti-submarine warfare vessels, and sloops were also designed for general purpose duties. Now, did I say that? No. These were a COSAG. I'm sure I didn't say they were combined diesel and gas because they weren't. They were COSAG, which is combined steam and gas, which is one of the reasons why they were so expensive. So much stuff I'm talking about today. And then I have to talk about, and at the end of this, it's going to be talking about Patreon for June. For while I'm away, hopefully, if we raise enough money with Shipshape. So many things to go through my head. Now, COSAG is the system put in these vessels. And it makes a lot of sense if you're nuts. It has good points. I'm sure it does. I'm sure it does. Basically, the idea was a gearboxes and clutches would enable either of the engines or both of them together to drive the shaft. Now, this is the advantage of giving the cruising efficiency and reliability of steam and the rapid acceleration and startup time of gas. It was used in county-class destroyers and tribal-class frigates, and the Spanish aircraft carrier Daedalus also used it. It is also, though, well, basically, you have enough fun in life trying to make one type of turbine work with your gearboxes. Trying to make 2 different types of turbine, both a gas and a steam turbine, work happily together to provide you with your system to be happy, to provide your system with all the power needs, is a nightmare few have been blessed with. We can all say lucky them. So, combined steam and gas, I would not consider it a good system. This is the reason why I started off with all diesel ones and going, diesel, because diesel and gas work well together because in many ways they're different systems, so you can make them work in differential harmony. However, steam turbines, gas turbines in the same system are both forms of turbines. And people go, well, that means they should work in parallel. No. The science for a steam turbine and a gas turbine, whilst theoretically both turbines, is actually quite different. And the maintenance cycle is very, very different. And the likelihood of each one blowing up is completely different circumstances contextualized. It's brilliant fun. Then we have combined gas, which, as said earlier, has a high-speed gas turbine and a cruising gas turbine. So basically, this is when you go, well, you know, I can do better. I can make a gas turbine which can not only give me high speed, I can make a cruising one. And I could have multiple gas turbines, so multiple points of potential turbine fun. And the fact is, I'm carrying 2 different types of turbines, so now the odds are, if it goes wrong, the parts of one can't fit in the other, so I have to make sure I have those stores completely labelled and separate. Because otherwise, I could end up in a lot of trouble. A lot of trouble. And you wouldn't be the first one. Now, these vessels, well, the first vessels to have them were the Cashin class destroyers. And the Cashins used 4 gas turbines. So they had 2 high speed and 2 cruising gas turbines. And some of them even did have 4 completely different turbines. Because they had them come from 2 different factories. For each. Just imagine the marine engineering officer in charge of that power plant. Just imagine how quickly they went from a spry 30-year-old to being a grey-haired, stressed out, hair falling out individual. I'd say about 30 in 1 week. Still fun. Now, interesting American vessels, which do have turbines as well. In this case, is the US Coast Guard Point Thatcher. The US Navy was actually slower to get into the gas turbines, mainly because they very helpfully kicked the US Coast Guard into doing it first. So basically, the US Navy decided to de-risk the whole problem with gas turbines by deploying the US Coast Guard to be their fall guys. It worked out okay. It did work out quite well. And actually the first major class for the US Navy, which were gas-powered, were the... it was the OHPs, Oliver Hazard Perrys, which were really it. But there was also the Sperances and then Arleigh Burkes and Ticos and lots of other vessels which were gas-powered. And are gas-powered. Combined gas and steam. This is if you don't think you've got enough stress in your life. Or rather, you think there's someone who you could, if you were really, really lucky, probably drive mildly insane. Because it's otherwise known as a marine compound power plant. And basically, they have a steam turbine which is driven by steam generated using the heat from the exhaust of the gas turbines. This is chosen because it's considered to be most efficient. Usually land-based electric power plants are used for this. However, currently no naval ship has this concept. Some cruise ships are equipped with a variation of it. And despite many people's attempts to try and make the Arleigh Burke class have it, no one has yet decided that they really want to see a mass resignation of the marine engineering officers of the US Navy. Because just think of all the things that could go wrong with this. It works, it's fine, I know, in land installations and on some very, very nice, vessels like the Celebrity Cruises Millennium. All these vessels, these lovely vessels, it works fine. Put it on a warship. Put it through the stresses a warship goes under. Put it on the threat of getting hit. Just imagine all the places all that liquid being piped around could end up going. Then watch a marine engineering officer cry. Now, finally, we come to what is probably the most sensible system we have for gas and any system. However, as I've said before on Type 45, and I have no qualms putting this up here, this is not the system as would have been hopefully fitted. Again, as if you listen to today's bilge pumps, which will be out, when this goes live, that will also gone live. Well, if you listen to that, you will hear Naval give a beautiful explanation of what happened in the Type 45 project, whereby the Royal Navy put in for a far larger vessel, and the government decided to pick, wanted to build a far smaller vessel on the theory that smaller would be cheaper. And then everything had to be cut down for it. So a beautiful system which was going to involve 3 turbines and roughly 6 diesel generators in 3 combined power packs, each made up of a turbine and a couple of generators, which would mean that you could turn off any one of them, still have enough power to run all the systems, and use that time to refit and maintain one while underway. It would have all been very, very efficient and would work beautifully. But instead, we are now adding in extra diesel generators and more powerful diesel generators in an upgrade to actually give them the power they need, which we can do because of integrated electric propulsion. And what's really interesting about this system is you can go back and you can look at various American ships in the 1910s and a few other systems that are being built in that period, and you can see that people are actually pushing for it. So again, it's one of those things of integrated electric propulsion, for me, makes most sense with naval vessels. Because if you think about it, you can produce a really survivable system. You can produce self-contained power units, which will provide you all the power you need, but can be separated off and don't have to have massive shafts running through the systems, which can now water through bulkheads and all sorts of things. And it means you can separate them off so that they don't have to be all maintained together. They can be spread about the hull as much as you can, maybe mounted in parallel or series, divided up by suitable bulkheads so that they're survivable. So one hit doesn't take them all out. And you can have multiple of these. It's an interesting idea when you start to think about it. If capital ships, etc., had moved onto such a system, and cruisers and capital ships and even smaller ships had moved onto such a system, perhaps using gas, but maybe using steam or any other system, in the run-up to World War II. If you go through some of the ships which were lost, and then you have the scenario of, well, actually no, they don't have the holes between the bulkheads to let the shafts go through, because they don't need to have long shafts, and they have different power systems. Maybe they have an auxiliary propeller system, and they have the different power generation systems. They don't lose power, they therefore can keep their pumps running at a higher efficiency, because if you have main power, you can have your pumps running far better than you have on auxiliary power. And they can get engines going, and suddenly it makes ships far more survivable. So really, when we're talking about gas propulsion and we're talking about gas power these days, we're talking about IEP. And that's really where we're heading, especially when we're looking at weapon systems which might require a large amount of power as well. Think about this system, add in capacitors, add in, which basically are super duper batteries, add in probably some more power generation, and you probably have a system which can be used to support lasers and other future weapon systems. Electromagnetic radiation based weaponry. So, I hope you enjoyed this introduction to gas turbines and a little bit of history. They're kind of cool. And I'd like to hear your views on it, on whether or not you think the 1920s could have been more interesting. 1920s and 30s could have been more interesting if they had got some variation of gas power to work. I think the best system, and the system which you could, so many things are edging so close towards it. I think if you got a version of IEP working in the 1920s and 30s, I think that could have been really, really interesting. I think the whole quite quite a lot of the ships that are built could have been very different if you'd had a variation of IEP. Very different. Right then. Now, before we finish, let's have a look at the June suggestions, because when this goes live, there's a link down below, but also the Patreon vote will go live. And I'm not showing the Patreon vote this time, I'm just showing the Patreon suggestions. The reason I'm not showing the Patreon vote is because I'm going to have to go through all these questions, and there are lots of them. Lots of wonderful suggestions. There are 41 comments overall. Many of them have multiple questions in them, and that produced more questions than I'm allowed for Patreon. So I wanted to say thank you to everyone for all your wonderful questions. They are really cool. They're really interesting. And I have tried to go through and pick which ones I think I can do best justice in May while prepping to hopefully go away in June. So, it's going to be fun. There is going to be a vote lasting for a week. At the same time as there is a vote going on for that for a week, there is probably going to be the Patreon suggestions for May live, because that's going to be live next week. So it's going to be fun. But basically my plan is for the votes to last till next Thursday. Not this coming Thursday, but a Thursday a week today. Well, no, Thursday a week from on Thursday this week. So, the 27th. And I'm hoping you're all going to enjoy it. Now, as said, for June, the top 4 are going to be made into recorded videos, which will be premieres. So, they're going to be premiere videos, which I hope you will enjoy. June, as you can see, is going to be fairly full. There are going to be a lot of things for you to see, and there's going to be live videos as well, if everything goes to plan, from all places, all sorts of places in Australia, as the very nice Shipshape crew go for a wander around. So, as said earlier, you should find below links to Shipshape. You should find a link to the discussion of marine gas turbines, and you should find a link to Patreon and the Patreon vote, which will be live for June. And thank you very much, everyone. I hope you enjoyed. And let's go back to the slideshow. See what we've got coming up. We have, of course, well, I know what we've got coming up. I'm not sure why it's not showing up, but I know what we've got coming up. We have, this week, we have Red Storm Rising. We have the Cold War conflict, 1980, a NATO doctrine, anticipated outcome of a conventional GUIK naval conflict. Basically a very interesting version of a stalemate at certain points, but that's what you need. It'll be interesting. And then we also have, next week, we have steam battleships. Woohoo! Yes, the vessels that become between ironclads and sovereign battleships, Royal Sovereign style battleships. Thank you very much, everyone. Take care. Have a nice day.